everyone, this video is on Midsegment Theorem and coordinate proof. It's an introduction with some definitions and examples. So basically the first thing we're going to do is look at the vocabulary. A midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. So here would be like two sides of the triangle. All right. A coordinate proof involves placing geometric figures in a coordinate plane, which we'll do at the end of the video. So here's an example regarding windows. A large triangular window is segmented as shown. In the diagram, DF, this line here, and EF are segments of triangle ABC. Find DF and AB. So basically, this is the midpoint of BC, and this one is the midpoint of AB. So DF equals 1/2 of BC. So DF, and I'll do this in green, DF is 1/2 of DE. So that's this formula right here of BC. So we know it's 90, and 1/2 of 90 inches is going to be 45 inches. All right, and AB, so AB is this line here, is 2 times FE, because these two lines are parallel here. So AB is 2 times FE, so 2 times 45 inches equals 90 inches. All right, and here's our example again. It says, in example 1, consider triangle ADF. So let's draw that, ADF, this triangle. What is the midsegment opposite DF? So basically, we know this is 90, and if I do a midsegment here, what would that be? So you're going to take our formula and say that's going to be 1/2 of DF. Well, DF is 45 inches, so that equals 1/2 of 45 inches, which equals 22.5 inches. And I'm running out of room, but 22.5. Okay, in example 2, it says, in the diagram, it says OS equals SP. So that means S is the midpoint, since it cuts it into half. And PT equals TR. So this is also a midpoint. Just like we had here, these two are mid segments here. So it's almost the same. Show that QR is parallel to ST. So we want to show that this whole line is parallel to this line. So it says because they equal, S is the midpoint. We already talked about that, and T is the midpoint. So we already got S and T are midpoints because it cuts the segment in half. Then ST must be a midsegment of triangle PQR. R. So here's BQR. So ST is the mid segment of that by definition, and therefore QR is parallel to ST by the mid-segment theorem. So that by the mid-segment theorem, we can go back this way as well. So if DE equals 1/2 of AC, then DE is parallel to AC. All right. Now this is the part we talked about earlier with that vocabulary word about doing proofs via the coordinate plane. We're going to place each figure in a coordinate plane in a way that is convenient for finding side links and assign coordinates to each vertex. So here's your square. I didn't put any values. I just put side, and it's labeled here. Okay, let's see what this says. The square represents a general square because the coordinates are based only on definition of a square. All right, so then the acute angle, we want all sides less than 90 degrees. So we just put it on the coordinate plane and usually always place it on the origin. Makes it easier. And S is your side length. And for B, this one, we need to use 3 different variables. So we used A, H, and B. So we're going to be getting more and more into coordinate plane type proofs. So here's an example 4. Find the length and midpoint of a diagonal of the square. So we're drawing the diagonal right here and doing its midpoint. And we're looking at this one. All right. Assign letters. So we assigned A, B, C, and D. And we were trying to find the length. Since this is D and this is B, find this length. So since we're starting at the origin, our 2 points are point 1 is 0, 0, which that's our point D, and our point 2 is SS, and we're calling that point B. And then you just use your distance formula, and you're going to get, let's go over this. When you take care of this, that's going to be square root of 2s squared, and you can break this up. And square root of a square is just that value there. So we get s square root of 2. And here's your midpoint formula. And we're using our same points here to find the midpoint. And it simplifies to s divided by 2, comma s divided by 2. And finally, this is the vocabulary I was talking about, a coordinate proof. A coordinate proof involves placing geometric figures in a coordinate plane. So basically, they want us to place an obtuse scaling triangle in that is convenient for finding side lengths. So remember on the other example, we need 3 variables. In this case, we're using C, H, and B. So, and we're using H a lot because this is the height. Usually with triangles, you have the height. And you could have used A or B or C. And then always have 0, 0. We always want to go with the origin. Now, in example 4, I didn't put example 4 here. Let's see what it says. What do you notice? Explain why this is true for all squares. So basically, if you have a square, all the sides are the same. So this is true for all squares because when you do the diagonal, the s's will all be the same. And this is true for all squares because the coordinates are based only on the definition of a square. Okay, and that's it. Thank you. Have a nice day. Bye-bye.
Class, Miss Shaw's class. Boy, I love math. Miss Shaw's class, Miss Shaw's class.
Don't fail. Watch Miss Shaw's videos for free.